Welcome everybody to today's alumni panel. I am super excited to have Greg and Benedicte and Katie with us. They are like amazing, fantastic humans and individuals and brilliant innovators and engineers. So like this is like a super exciting panel. I hope everybody, as you listen to today's conversation, gets the chance to hear how awesome they all are, but also how successful they've been in their careers. So as everybody knows, the sort of way we run things is there's a Slido poll, which I'm going to put into chat, where you can stick questions in. These are questions you can submit anonymously. You can also put your name on them, but you can also upvote people's questions that they have. We'll kick off the panel with some set questions just to kind of get things going. And then I'll move to any questions that are messaged to me in chat, messaged to everyone in chat, or stuck on the Slido poll. So you have three different ways you can submit questions to get answered by our panelists. At the end, if we have time, although it depends on how the sort of discussion is going, I do have rapid fire questions for our panelists for 1 to 2 word responses, kind of asking just a quick takeaway on something that's been impactful to their career. So we'll see if we can get to those at the end, but if not, that's also okay as well. And I'll stick the link to the Slido in the chat a couple more times throughout, just in case anybody joins late. If you're in the audience and you don't mind putting your video on, just so we have like faces we can see, that's always great. If you're not in a space or don't feel comfortable doing that, that is also okay. But if you are in a space where you can do that, we love to see your lovely faces as well. Okay, y'all all know who I am, but I want to give the floor over to our panelists for them to introduce themselves. Like I said, they're amazing. I could go on forever about how awesome they are, but I'll let them tell you whatever level of awesomeness they want to share about themselves. So maybe we'll get started with Greg. Do you want to kick off with an introduction, open interpretation here of what I mean by introduction, about anything you want to share before we get started with the panel?
Yeah, absolutely. Yeah, it's great to be here with everybody. My name is Greg Newbloom. I'm the founder and CEO of Membrion. Membrion is a spin out from the ChemE department at the UW, where I did my my PhD and a postdoc. We're focused on treatment of harsh industrial wastewater streams, help companies to clean those up. Yeah, as I mentioned, my background, I'm a ChemE by training, did my undergrad at Oregon State, moved up to the Seattle area about 15 years ago to do my PhD, and have been up here ever since. And so I love being up here. Yeah, been working on Membrion for the last 8 years. We work with a lot of great companies, have some fantastic investors. I'm excited to share a little bit more about that kind of entrepreneurial career path. So.
Thanks, Greg. Greg has also just done an amazing job of successfully fundraising to grow his company over the last like foundational years. Oh, hang on, let me get.
How important is this?
Muted people. There we go. So if y'all have questions about taking the risk and starting up a company with your ChemE degree, definitely please direct those to Greg. We're gonna move to Katie, who's actually on an interesting flip side of this, of thinking about investing in technology and new technologies that are being developed. So Katie, would you give us an introduction, and again, open-ended way you want to interpret introduction?
Yeah, definitely. Thanks so much for having me, and so great to be here today with all of you. Let's see, I'm from the Washington area. I was a UW ChemE undergrad, graduated in 2015. I got into ChemE initially having kind of experience working at like the local oil refinery. Started working there in the summers when I was 18 years old. It was a higher paying job than really anything else in the county. And so after my chemical engineering degree, I went and worked for Shell as a process engineer for about 4 years. And then I ended up making a switch and working in the climate space at the time was a growth stage silicon anode company for lithium ion battery applications. I was a product engineer there. And then went to business school and am relatively new to the investor hat. So I now am an investor with Prelude Ventures. We are an early stage climate-focused venture capital firm with about $2 billion under management. And we focus on investing in seed to Series B deep technologies that will help decarbonize the economy. So really great to have you all.
Thanks, Katie. We're definitely always getting questions about timing of making decisions around graduate degree, like post-bachelor's degrees. So I know you and Benedict will have input on kind of thinking about this. So we'll certainly make sure we circle back. Benedict, will you give us an introduction? I think everybody on the panel, everybody who's joining us will also get to see this really cool intersectionality between ChemE training and civil and environmental training through Benedict's experience. So Benedict, please introduce yourself to everybody.
Hi, everybody. So I'm Benedicte Diakubama. I'm originally from Congo in Central Africa. I landed in the United States through Portland 10 years ago. So, and then moved to Washington for my undergrad studies. I was a transfer student. I went to community college, Bellevue Community College, went to UW for my ChemE, graduated 2019. Went to work for a year. Prior during my undergrad, I was doing research in lithium-ion battery in Umber Lab, but then one of the summer I just wanted to take a break and try consulting. So I tried with Ecolab. I was a cell engineer going through different heavy industry like power plant, chemical plant, talking about corrosion, like water corrosion, and how to mitigate it with narco chemical. So I was really interested in consulting and water. So after my graduation, I started working for an oceanographic company for a couple of months, and then COVID happened. I lost my job, and then I was like, okay, what to do during that time? I decided to go back to school for the data science program in ChemE, and upon graduation, I wanted to get into water, and so I was looking into Jacobs. I joined Jacobs before graduating, and then got converted to full-time. So I was doing I started doing data science project, and then I was interested into the water space, and then right now I'm getting into the process mechanical space, and then I'm looking maybe in the future getting another master in water system in civil. So yeah.
Thanks, Benedict. I think one thing that is even just super clear to me from all three of your introductions is how much there's probably ongoing learning and ongoing like education in your job. So can y'all give us like a sense of your day-to-day role, and because you've kind of been in your positions or sort of driving your careers for a couple of years, how has that evolved over time? What's the day-to-day currently look like, and are there any distinct differences from when you started in sort of the area that you're currently in? And maybe Greg will kick it to you to start.
Yeah, so my day-to-day is completely different than when I started 8 years ago. I think, when I was starting Membrion, I spent a good amount of time actually in the lab, running experiments, working on how to build a product. I'd say now the vast majority of my time is working, is actually doing a lot of kind of sales, working directly with customers, talking with investors. It's a lot of talking. That's the vast majority of my day. And yeah, a lot more like finance and things like that than I was ever expecting to have to get into. But I've kind of picked up a quasi MBA along the way over the last 8 years, just as a kind of learning as I go approach. So it's very much, there is a lot of things to kind of learn and add on the back end with where I've been.
Yeah, thanks, Greg. I think it's also brings up a good question, which I'll direct to Katie, in line of that same question of like, what's your day-to-day like in sort of your current role? How much of that day-to-day is influenced by the fact that you did get an MBA kind of as you were moving through your career? And was that MBA to move into a role like what you're doing now to do the day-to-day? Or was it something that was just kind of like an interest, a passion project, a hobby type of thing that then allowed you to step into a slightly different career trajectory?
Yeah, good question. So I was a practicing engineer for about 8 years. And when I got my MBA, I really wanted to just have a broader perspective within the companies that I was working within. And so, I was thinking I would go into product management maybe. I think that tends to be a pretty common next step for a lot of engineers, especially here in the Bay and startups. And so initially I was like, I'm just going to go back and be an operator at an early stage company. And then through my MBA, I took an experiential learning class. I kid you not, these things actually sometimes change your life. And it was going to be a 10-hour a week kind of integration with a local climate venture capital firm, kind of like an internship. I got class credit for it. And it quickly went from just 10 hours a week to like 90% of my waking hours. And I realized that I really loved it and had a passion for it. And I think part of my learning with all of that was that deep tech investing for climate is actually a lot of engineering and a lot of finance. And so, having been a practicing engineer for a long time, and then also having my MBA, it really was kind of the place where I felt like I could be most additional. And so it was a bit of a last minute pivot in just the last couple months of my MBA, honestly, but very, very happy that I ended up kind of making that decision and then chasing after it. So.
Well, it sounds like, too, having that 8 years of like practical engineering experience, I imagine, Greg, this is true for you, too, of being the person working at the bench, really informs and facilitates kind of your ability to see the big picture, but also to stay connected to the people who are so critical to doing the day-to-day and working with, clients or investors or, people who are going to actually be developing the technology. I think that sounds like a critical component to both of your roles as well, and like how a way you can leverage that experience from like the early years of immediately out of the engineering degree. Benedicte, what about your experience? Because you've also gone through an evolution of starting in kind of, I guess, what many would classify as more of a traditional sort of entry-level engineering job with a bachelor's degree, and then doing adding a master's in data science. What's your current day-to-day look like in your current job, and how is that informing kind of that ongoing education or those ongoing training components that you've been seeking out?
Yeah, so when I started as an intern, first I was doing a lot of SQL and a lot of financing kind of, and then I'm moving into working on the dashboard of helping operator get the machine learning support to help them with dosage. And then for me, I wanted to learn more about the engineering to inform the data science part of it. That's why I wanted to do the data science attached to chemical engineering. I didn't want to be just a data scientist. So, and from there, because I wanted to learn more about the water treatment, learn more about the drinking water treatment, I saw that I had the gap because I don't have the technical training as a people that got an environmental engineering degree. So that's informing why I want to get that adding educational foundation to help me move forward and just learn more, being able to design treatment plan. But the ChemE comes in place because in chemical engineering, I took process classes. So that always come into place because you have an idea of how a process will work, what you need, like water pressure, you have an idea of it. So that always come into place. It's just the fundamental knowledge of the treatment that sometimes lacking. Now I know at least what question I need to ask because I've been in a place where I didn't know what question to ask because I had no idea. But working through project, I'm getting a sense of it, and the more I'm working through projects, I'm like, I really like this, and I want to invest into getting that degree.
So you mentioned process controls, and I'll flip this question around to everybody. What classes do you like? What do you most connect with your ChemE training? Are there certain skills? Are there certain classes that really just resonated with you and stay with you as sort of being critical to the work that you're doing now? Benedicte, since you brought up process controls, I'll start there. But Greg and Katie, I'm not expecting you to remember like course numbers. Like
I don't even remember the course numbers, so I don't think they will. I mean,
the faculty know the course numbers either. I think it's just me at this stage. So
I don't know what the process. I know we took a process control. We talked about the PLC. We did some MATLAB into that class, but that because you have like a PID where there's like the process part of it, how will all those sensors will work. So that always get me back into that class. Although I don't remember everything, but I know like, oh, I remember this and that. Also fluid, because water will go through pipes, right? And you have to remember, although I was really bad with the velocity profile, I think they always come and catch me. I have to remember about head loss. So those are the two classes that I feel like they come back all the time, my day-to-day job.
Awesome. I love the throwback to fluid mechanics. I think that class trips up a lot of people. So Greg, all right, I'm throwing it to you, Greg. What are there certain ChemE courses or ChemE like skills that maybe were across courses that especially were valuable when you were getting started in your career, but also kind of have informed just the ongoing technology that you're developing?
Yeah, I mean, as far as the technology side of things, the reason I actually came to the UW initially was to study under Professor Berg in ChemE for his colloid and surface science work, and I ended up ultimately studying under Lilo Pozo, who's phenomenal. But ultimately, like that like discipline really is at the core of everything we do at Membrion, and it makes it really that kind of combination with the work done at kind of molecular engineering and sciences and nanotechnology really sets us apart. But I'd say on a day-to-day basis, the amount of times that we talk about mass balances is it shows up all the time. And it's interesting because it also it shows up across, like we use it as like engineers within the company, but then it also shows up in finance on balance sheets and things like that. The same like concept of needing that balance is seen all over the place. So it is quite interesting how a lot of these subject matters kind of have a way of translating even across professional bounds.
I like that you also bring up the principles underlying some of these things like mass and like material and energy balances, right? Like we talk about that in a specific context in the curriculum, but then you think about in your personal life, in your job, right? Where like you actually have to be doing this kind of on a day-to-day basis with finances in particular is a great example of that. But I imagine too, also people, right? Like thinking about resources and how resource distribution works and thinking about that really holistically. I imagine that's also a critical component of the work that you do, especially as CEO of a company, to kind of broadening that definition even more.
It's a lot of balancing. We have so many people, we have so much money, we have to make this amount of progress so we can get people like Katie to invest in our company. We have those are the critical things to figure out how all those pieces fit together. And I think ChemE does a really unique job kind of setting the foundation for a lot of that.
While I've got you on this, Greg, was there anything that you felt was distinctly unique in the PhD training and skill set that either added to the bachelor's degree in ChemE that provided sort of those foundational skills that really was critical to kind of the startup, particularly the startup space or the entrepreneurial space?
I think the biggest thing about a PhD in particular is the resilience aspect of it. I mean, the vast majority of your PhD, you are spent kind of scratching your head about why something isn't working and why things keep failing, and it's very like frustrating, but you keep kind of digging and figuring out a path to success. And I think that and the ability to really learn how to like teach yourself a subject have been fundamental to kind of being an entrepreneur, where I don't know a lot about marketing, but I don't have enough money to hire someone for marketing, at least not a few years ago I didn't. And so how are we going to bridge that gap? Well, I got to figure that out. And so I think that I think it was a lot more of the fundamental skills, less so the technical stuff that I learned in my PhD. Certainly was critical for inventing Membrion's technology, but it's actually a lot of the kind of interpersonal or personal skills that have been much more critical in the long run.
Yeah, I think that's a great perspective to share, and we'll definitely, I want to circle back to some of these aspects of kind of developing those interpersonal skills, and particularly doing that as early on as possible in like undergraduate training, like ways we can enhance that. Katie, I want to get to your, I know that you're in the venture capitalist space, and many people would not associate that with chemical engineering, at least in terms of like a direct connection. What are, where do you see the connections? What are the classes or concepts or foundational knowledge pieces that you feel like influence, that you learned as a ChemE, that you feel like influence your day to day?
Yeah, it's actually shockingly technical. In a lot of ways, even it feels more technical than my last engineering role that I had. The context there is that, we are investing in deep technologies. What that means really is that a lot of it is like professor invented technologies that are kind of first ever to be commercialized. And so I'm having conversations day in, day out about, with folks that have PhDs in their particular field and have thus invented, a new novel tech that they want to bring to market.
And they're also professors, so cannot talk about it generally or broadly.
Yeah, so it's like hard, right? But like, and literally, I was thinking about like all these classes, like process control. Just a few weeks ago, I was looking at a new like adaptive AI for new PDC controllers for industrial applications. There's like point source carbon capture that requires absorption and like, a type of like amine absorption efficiency that you have to think about. We're looking at investing in a new like EV battery pack technology, right? That requires like an understanding of heat transfer and electrochemical applications. The list goes on and on, like process design. We have one portfolio company that is a chemical manufacturer, and so they're transitioning their first production scale line. And so, when I'm interacting with even the founders in our own portfolio, I have to kind of talk their language, and I also am required to do technical diligence on potential investments, right?
Yeah.
And rely on, maybe I don't have a PhD level of expertise in a certain area, but because of my experience or because of my degree, I can talk with folks that also have chemies that are maybe more knowledgeable, and then I can get up to speed more quickly about those things. But it's shocking how applicable all these classes are to my job on the day-to-day. Yeah.
Well, there is a part of our chemical engineering profession that thinks that every ChemE should get an MBA as well, to better understand, like basically take the economic part you learn in senior design classes, right, and kind of broaden it to like a broader understanding of financing and budgeting and all that sort of stuff. And I think there probably is some truth to that, right?
I think chemies that get a true MBA on top of it are like virtually unstoppable people.
Yeah.
Like they're just you can like do so much with that combination. It's pretty crazy.
Yeah, I've heard that discussed before too, because I think it also broadens the where they can be used within a company, and I mean used in like a good way, like where their skill sets are really really relevant. So not that we're to everybody in the audience saying that you have to get an MBA, but it's just, I think it's an interesting piece that has really nice synergy with the ChemE training. And I like that you make those connections so directly between the coursework, like the specific training in the coursework that then becomes useful in your day to day. I'm gonna like step back a minute and ask what made y'all interested in the ChemE degree in the first place, because you have very strong connections between your training and what you do day to day, and I don't get the sense that's just because of the phrasing of how I'm asking you the questions. But like, what was appealing to you, particularly with such a strong interest in sort of energy, environment, thinking about climate change, thinking about sustainability, thinking about clean water, clean air? Where did the interest in ChemE start for you? Was it application specific? Was it degree specific? Can you kind of give our in-training chemies your insights into that? Maybe we'll go Katie first, because we.
Oh man, my answer is not the good answer. I don't think I have the good answer on this one.
Is it because you like chemistry? Is that your answer?
No, because I was a third generation UW ChemE, And
Yes,
so
this is
I did
true.
not really have a lot of choice. Like this was just, I was born into being a UW ChemE, right? But
And your brother didn't either, who, for everybody in the
no,
audience, is also a recent
yeah,
alum.
yes, exactly. So there was a part of that, right? Like a huge family influence, but I would say like, not that working in a refinery is like a very sexy thing to do at all, but I was really young when I started working in manufacturing plants, and like refineries are incredibly complex, and I was a very curious, inquisitive person, and I wanted to figure out how it all worked together. And so I think that there was a lot of motivation in that. And I think as I've gotten older, I've developed a lot more pride around being a ChemE, in just the versatility it's given me. I feel like I can interact with all different kinds of engineers, and so like that generalist ChemE mindset, I still think that that's incredibly important and useful skill set today. And now that I've gotten older in my career, and I'm talking to a lot of entrepreneurs and founders, like a lot of them are chemical engineers, and I'm highly motivated to get more and more of the younger generation like involved, because we do actually need that. We really need that skill set if we're going to try and like impact on the huge climate risk that we have. So I think my motivations have changed quite a bit from like a really strong family influence, and kind of like trying to maybe please other people, and going down what is like the right path, and then ultimately developing my own pride around kind of being a practicing engineer and how that can impact the world. So
I think that's a really great perspective to share, though, because kind of there's sometimes paths that we either feel like we fall into or kind of get into for reasons that we may not own, but then kind of growing into owning it, and owning it in a way that we can take pride in and adapt and kind of apply in the way that we want to be applying it, I think is really can be empowering, but also can be important to hear, because it can feel really debilitating sometimes to think that you might get stuck, or that like things are out of your control and you need to do these things for X, Y, and Z, and they might not be reasons that you would have initially done them, but you can grow into it and own it and find a lot of satisfaction and fulfillment in doing it. So I think that's actually a really great perspective to share. I'm going to put Benedicte on the spot for sharing what I anticipate will be a different perspective, Benedicte, because you came from, you're an international student. As you mentioned, you came from Bellevue, so transferred in, which I know a lot of our students can relate to as well. About 35% of our students in the department or community college students who have transferred to UW. I know from working with you over the years that you've got a very strong commitment to, creating a more climate friendly, like sustainable world. What drew you to ChemE in the first place? And was it ChemE specifically, or was it kind of a, opportunities to take ChemE and then add and do pluses onto it?
Yeah, I think I was taking ChemE and add because first coming from Congo, I had a chance to intern out just before graduating high school. I worked for it's a industry back home. They transform palm oil to soap. So that's why I was interned there, and it was just like so amazed being in the industry, doing like the process portion of going from pure product to a finished product. But I thought that was maybe chemistry. So because back home there's not chemical engineering, I didn't know what was chemical engineering until I landed here. I heard chemical engineering, and also I was so scared of being stuck. I didn't want to pick a major and then being stuck in case I didn't like it. Mm-hmm. So ChemE seemed to be just that great major stepping stone to whatever. And also I started medical school back home. I had 1 year of medical school, and I heard like with ChemE, in case I don't want to go to medical school, I can do other things, but it's also a great gateway to medical school. So that's why I chose ChemE, because I wasn't I didn't decide yet on what I wanted to do. So ChemE was just that great place. And then just as Katie said, more and more I felt a lot of pride of being a ChemE. Meeting when I started with Jacobs, I met a ton of people that were undergrad ChemE, that were in high executive position, and that ChemE background just gives you that perspective of not that all other engineers are not hardworking, or no other major are not as hardworking, but I think ChemE is really hard, and you learn to figure out stuff. So that resilience you bring it into work, and you are able to open different door with it. So that's why the ChemE, and also the background of the clean energy, because I worked with Umbrella Lab, that it's specific clean energy lab. We were doing lithium ion battery, so that's where that sparked that interest of clean energy, and water just came along. So yeah.
Yeah, I like the water just came along. That's also a good like pun of just, you know, kind of float into your life.
Yes.
But I think like, but one thing both you and Katie, I feel like are emphasizing too, is that you get to work on these really, you know, even you started in working on these very complex problems early on in your experiences, and kind of having appreciation for seeing the full process of the kind of the depth of complexity of those, and then seeing how ChemE could be leveraged in sort of addressing these complex problems, and now doing so in ways where you've got portfolios of complex problems that people are coming to you with, you know, and being able to tailor and adapt your sort of skills and your expertise to those different client-based, you know, challenges that they're bringing to you, I think is also a really cool demonstration of how that continues to adapt over time, how that like ChemE training continues to adapt. Greg, I'm gonna ask this to you from two perspectives of the value of the ChemE degree to you, but also you do a lot of hiring of ChemEs and hiring of other obviously disciplines and trainees. From both sides, from both the perspective of you getting a ChemE degree, where, you know, what appealed to you in that? And then what do you think are the strengths that ChemEs bring, or that you look for when you're hiring chemical engineers? So you have many at your company, and many of our alumni, and thank you for doing that.
Yes, of course. Yeah. Yeah, so I think, you know, for me personally, I think, you know, mine I think is maybe a more traditional answer, which is I liked chemistry and I liked math, and that seemed like a good combination of the two. And so so I went, and if you look at most, at least, you know, 20 years ago when I started my undergrad, if you looked at most of the pay scales, chemies were always at the top. So I was like, this is great, right? Two things I like, and you get paid well to do it.
We're still at the top. I just want to throw that out there to everybody.
Okay, great, fantastic. I haven't looked recently, so that's great. I love that. And you know, so I thought, like, you know, initially it was that, and then as I got in, I realized, you know, just the like, you could really do anything you wanted with the degree. You go to any field you want. There's chemies everywhere. And so then just I think, as you know, as Katie and Benedicte have highlighted, just the flexibility of what you can do with the degree is incredible, and the difficulty of the problems you get to solve. And I think that, you know, we do hire. We have quite a few chemies that work at Membrion, and I think that really, like, what kind of is unique about that degree is the kind of ability to solve problems in non-traditional ways and connect things, because I think as a chemie you really learn how to take things down to the fundamental and then back out. And I feel like that's something that not every degree emphasizes. Some will emphasize kind of getting to the fundamental or kind of practical problem solving. But I think ChemE is really unique in it forces you to get down to first principles and then build your way back out. And that's just a really unique way of thinking, and you can apply that obviously to a very ChemE specific problem, but you can also apply it to a not ChemE specific problem and get really unique kind of answers and perspectives, and so it is, I think, in a lot of ways a kind of a jack of all trades engineer. And so I think that that's, you know, especially in a startup where, you know, people are going to work on a lot of different things all the time. It's a very kind of useful skill set to be able to bring in.
Yeah, I think that's also, you know, that adaptability, flexibility is something that we often talk to our students about quite a bit. My follow-on question actually comes from a question we got last week in the panel discussion, but I'm going to throw it to y'all as well. And I've been kind of weaving in questions that I'm getting in direct message or elsewhere. How do you tangibly demonstrate the adaptability of the degree? So I know you've each mentioned kind of internship experiences or shadowing experiences from your undergrad training or later training. What do you think, like, if you were to give recommendations of types of experiences to get, are they entirely technically focused? Are they entirely soft skill focused? Are they kind of a combination of both? I'm sure that's probably closer to where the answer falls, but how do you balance when you have this time limited, training period of being an undergraduate? How do you kind of pick or choose or focus your energy and time into experiences that are complementary to the coursework or add to the coursework in a way that, Greg, to your point earlier, demonstrates that you are developing the skills that then allow you to tackle these sort of very adaptable, diverse, complex problems? And I think this is particularly important in thinking about the clean energy, like the energy and environment space, right? Because this field is rapidly evolving. It's becoming more and more prominent in ways that are good and bad, right? There's more political pressure, there's more political awareness, there's also more, social cultural challenges. Like there's, not to say this haven't existed, but there's just this elevated pressure that everybody's feeling around, particularly this field. So how do you get the skills as an undergraduate or early in your training to demonstrate that you can add value to a company, that you can add value in a discipline where you're going to have to do a lot of on-the-job training, but you have a really strong foundation? Does that question make sense? Sorry, it's a bit broad. It was a bit broad and garbly. I don't know I'll throw it out to any of you to answer if there's a.
I'll say like the way I gathered the experience or got my hand into different things was I already had the experience of classes. I was trying to go after things that I think the class education, the class training couldn't give it to me. Like, for example, I was still doing research. I was seeking to get my hand on like research experience. And when like the internship position came in was cell engineer, I mean, most of my peer wanted the process engineer title, but I just wanted to check it out. They told me like, yeah, your ChemE will be used into what you're using. The title may not say that, but like your training will be used. So I was like, why not? So I was trying to get experience that I couldn't get in class to add on top of what was already given. The training we're getting it's already part of the package of the degree. So, and along the way, going to all those different places or getting to those different doors, you gain some type of different soft skill required for the position or required for the task at that moment.
I think this is a great point you bring up about title too. And I think, Katie, this comes back to like when you were talking about, shadowing or doing work in refinery, but that's certainly away from the work that you're doing now, not getting caught up in the title of or like maybe the specific discipline or domain area where you're doing that training or those extra experiences that are complementary to classes. Is that a fair assessment to say that, kind of what you experience specifically in the domain area doesn't necessarily have to be exactly what you want to do after graduation?
Yeah. No, I mean, I would say like my first job in really more of the first couple like internships and co-ops I did, my sophomore year, for example, I, wanted to kind of get some type of work experience, right, for that sophomore summer. And I quite literally moved down to Deep East Texas and worked at like a petrochemical facility and worked tech sales, which I, didn't really see myself doing tech sales long term, right? But it was like, found kind of a way to say like, hey, I got my boots on the ground somewhere. I made some X type of impact. And, whether that's like incremental cost savings or, I feel like we unlocked or optimized a certain process or something like that. And then I worked with a team, which I feel like is really, really important in your kind of summer experience. And so the way that I've always thought about it is like, really you want to get yourself in the door, and like that first role is not going to be perfection, but what you want to do is just get incrementally closer to the thing that feels more, kind of like the longer term target for you. But I really think, especially thinking about like your sophomore, junior year, like getting team experience and then being able to say, that you were able to impact the business in some way is really important. And that's a really far cry from where I started in refining and manufacturing, which was like literally I was digitizing PDFs, like I was PDFing old design drawings in they had this like document vault that had like 70-year-old documents, and like that's literally how I got started in manufacturing. But like I was able to say like I've worked at a plant and like I know what a design drawing looks like, and then the next summer I got something just slightly better. So
I think it's like that. Well, there's probably a saying, a better way of phrasing this. Like there's that saying, right? That's like, you know, give 100% to the job that you're in to get whatever the job that you, Greg, you might actually know that saying better. I feel like this comes up in like, particularly startup entrepreneurial spaces all the time, but I imagine that you can, you know, having observed the growth of a company and built a company, also seen that evidenced in the people that you hire. I might be saying this in you know, this could be entirely inaccurate, but I'm positive you probably hired people that have never had experience in building membranes.
Yes,
right.
Absolutely. Yeah, no one's ever built the type of membrane that we make. They didn't exist before we created them, and so I do think that's a big part of it. And even, you know, reflecting on my own experience, so much of it is just, you know, getting your foot in any door, and then building from there, because it's so much easier to get opportunity number 2 than opportunity number 1. And each time, if you like, I can point towards people in our company who just, you know, they came in and, you know, it maybe wasn't the exact thing that they were wanting to do, but they just came in and crushed it. And when the next opportunity came over, it's like, wow, well, this person did so well, and this is actually better aligned with what they are interested in doing day to day. How much better are they going to do, you know, in this role than where they currently are? And so, I do think there's a lot to be said about building on that, with that kind of mindset of how do I build towards something that I am really excited about doing. But I do think initially leaning into that like technical side and doing that, it is important, you know, to really build on those skills. And the other, you know, soft stuff, I think it's maybe more important than the technical in the long run. But those are things that kind of build over time if you're cognizant and focused on them.
Yeah, and the technical, I feel like, is often where you get the foot in the door too, right? That initial foot in the door. Sorry, Katie, I didn't mean to cut you off.
Oh, no worries. I was just going to jump in to add what Greg said. I want to kind of add, because I feel like I should have added before that, like, get your foot in the door, but also you can still be strategic. And the question that I always ask myself is, like, at the end of this experience, what's the story I'm going to tell? Like, why did I go do that? Why does that make sense? And are there specific skills that I can kind of use or translate? I mean, that could even just be like, I've, you know, worked with a team, or I've worked in a really high, you know, high stress or high risk environment, or I've worked in production, or I've worked in research. Like, just make sure whatever, you know, what you're doing, that you can tell a story that is going to make a lot of sense to the next place that you want to go to. So that would just be the one gut check I would make.
Yeah, I like that. I think that's a great kind of accountability to hold yourself to, that there's purpose to it, right? There's going to be something intentional that you get out of it. But like that's something that you're thinking about up front. I do want to ask, I'm going to integrate 2 questions, one that I got in a direct message and one that's on Slido. You're all in an entrepreneurial space, and you're all operating, you know, at the interface of entrepreneurial sort of technology development, entrepreneurial investment. What inspired you about that aspect, and how do you think your sort of area will evolve in the context of where we need to see chemical engineers playing a role in energy and environment? What is the role? What is the bigger role and the bigger challenge that you see as important in sort of this entrepreneurial aspect of energy and environment? And I think you can all speak to it from like a consulting, the venture capitalist, or the startup company space, or just more broadly. You don't have to necessarily speak to it from each of those very specific things.
I'll say, so I used to hear when I was undergrad that most CEO were ChemE. I don't know if that's true, but I think the reason why ChemE they find themselves in the CEO position, entrepreneurial position, consult position, is because we have that wholesome perspective of when you look at like Aspen, for example, you're zooming into one area, but you're also looking at the entire process, how changing pressure here will go and change everything else down the pipe or down the downstream. So can we have that wholesome and then that zooming perspective that will help into those spaces where a little bit of work here in environmental or in clean water will impact 15 years, will impact the bigger picture. So I think I lost myself into the answering your question.
But I think you're making a great point though about this, like the things you are doing now in this space are going to impact 10, 15 years from now, right? And I saw like Greg nodding his head about that as well, that like these contributions today are going to make a difference longer term, right? Or hopefully make it like intended to make a difference longer term. Yeah.
Hopefully, yeah.
Yeah, no, I think that's that temporal impact I think is important. Greg, I saw you nodding your head at that. Is that a similar kind of thinking of long-term impact that you can have?
Yeah, I think long-term impact is certainly a big component of it. You know, there's just so like I think that especially once you have that kind of baseline knowledge, you start going and looking at like some of the problems, especially on the environmental side of things. They're just like they are so massive and pervasive. Like especially I didn't appreciate. I've been in the water sector for about 5 years now, not even my whole time at Membrion, and the amount of issues that exist that just have a direct impact on human life, the amount that we've poisoned our water sources universally across the globe, and now we're gonna have to figure out how to reverse that over the course of the next generations. It's just these are the biggest challenges that we have, and chemies are ripe to help solve each of these. Like you can look at really any major challenge that we have as a species, and chemies are really well positioned to be the ones at the forefront, leading, supporting how we get to where we're going. Even remember on some of the stuff that we encounter is like it's ridiculous that we still truck our wastewater across the country to treat it. The amount of, we come across companies, very advanced manufacturing companies that are literally loading trucks full of hazardous wastewater and driving them thousands of miles so that they can be disposed of, have mixed with concrete and disposed of in a landfill so that hopefully they don't leach out back into the groundwater supply with heavy metals. And this is the standard, just the way things are done. And so it's crazy. Like once you start getting into it, there's a level of craziness that exists within the way things are done. And I think as a chemie, it's just like, oh wow, I could figure out a better way to do that. And then being able to actually go and do it's just super, super rewarding.
And there's got to be a better way to do it, right?
There's got to be a better way, right? Exactly.
There's got to be a better way. Katie, I'll give you the last word on that. As somebody who's investing in the technologies that are hopefully a better way, what's your kind of inspiration and vision for the criticalness of having chemies in this space, but also the sort of future and challenges that particularly the clean energy, clean environment field faces?
Yeah, I think the original inspiration was really my time working as an engineer at Sila, and we launched the first commercial product of the silicon anode, material, and then also built the first production line. And then, the next step from that is a big production line actually in Washington, which is the material is going to go into a lot of Panasonic batteries and first Mercedes, but then mass market vehicles. And what you're going to get out of that is a much better performing electric vehicle. And hopefully, that will continue to spur demand in the sector. And so I think my initial, it's kind of similar to what Benedicte said, was like, gosh, I was working on this one project and I was really focused, and 10 years from now, that's going to hopefully have a really massive impact on just the technology available in this space. And when I look across our portfolio now and the huge problems that they're working to solve, I mean, one company is working on reducing copper needed for lithium-ion batteries, so hopefully that's a 20% cost decrease for EV lithium-ion batteries globally. Like, that would be huge. Another company is like a hyper-efficient window company that can essentially create a heat flux barrier equivalent to just a wall. Like, more efficient than anything else we have in the market, right? And when you apply that and scale that across a lot of homes, there's a really big impact. Recently, we've been talking a lot. Obviously, I live in California now, and we talk a lot about wildfires here. As you know, it's a big issue in or in Washington as well. But like, we're looking at investing in some robotic fire tech mitigation companies. And when you think not just only about the CO2 impact of fires, but also the health and hazard and property risk associated with fires, like, gosh, the motivation to make a difference in that space is just enormous. So anyways, I think it kind of came from firsthand experience initially, and then just being really inspired by the impact that the entrepreneurs that we invest in can have.
Yeah, I think that's a great sort of closing, like from all of you, to kind of highlight there are these grand global challenges where we critically need, adaptable, fundamentally like well-trained in the fundamentals, adaptable engineers who can think like at the very complex level, but then be able to boil it down to the most critical contributing parts that need to be tuned or adapted or modified. I think that's seeing that kind of play out through your 3 careers and your 3 like inspirations for what you do, I think has been really valuable for everybody to hear about. So thank you for taking the time to share your experiences, to answering the questions. I tried to weave in questions I was getting in direct message chat from with the set questions that we had. I know we had a few we didn't get to. So to everybody who I know people have to run to their next class, but we'll see. I'll send out the remaining questions to our panelists if they always up to them. But if they want to add any quick notes or responses to those, I'll post those in our follow-up message on the panel discussion. Just a reminder to everybody in the audience, you'll have the reflection post posted tomorrow for this panel and your lab experience on Thursday. And I'll put notes from this on all the things that Benedicte and Greg and Katie mentioned about different classes, different experiences, research opportunities, et cetera, that were mentioned throughout as well. For everybody who is still on, because I know a few people had to run to class, if we can just do like an emoji response, round of applause, whatever that looks like on Zoom. For everybody that's still there, we'll give a little reaction, high five thing going on. Which I can see really nicely in the chat, but maybe isn't because I have you all pinned, so you can't necessarily see them all. But thank you so much to all 3 of you for sharing your insights and perspectives and your journeys. That's been really valuable and exciting to hear about. And we really appreciate your time as well.
Thank you for having us.
Yeah, thanks.
Thank you.